Today, I'm going to be working out an example problem from an actual 2016 AP release test, a free response rate. So our directions say questions 1, 4, and 5 are short free response questions that require about 13 minutes each to answer and are worth 7 points each. Question 2 and 3 are long free response questions that require about 25 minutes each to answer and are worth 12 points each. Show your work for each part in the space provided after that part. So for number 1, looks like we have a wheel on a ramp of angle theta. A wooden wheel of mass m, consisting of a rim with spokes, rolls down a ramp that makes an angle theta with the horizontal as shown above. The ramp exerts a force of static friction on the wheel so that the wheel rolls without slipping. On the diagram below, draw and label the forces that act on the wheel as it rolls down the ramp, which is indicated by the dashed line. To clearly indicate at which point on the wheel each force is exerted, draw each force as a distinct arrow starting on and pointing away from the point at which the force is exerted. The lengths of the arrows need not indicate the relative magnitudes of the forces. Okay, so let's start with our forces. So we have the force of gravity working downward on the wheel. And then we have force normal working parallel from the surface. And we have the frictional force working opposite of the direction of the wheel against the ramp. So there are only 3 forces acting on the wheel: the gravitational force, the static frictional force, and the normal force. Okay, part 2. As the wheel rolls down the ramp, which force causes a change in angular velocity of the wheel with respect to the center of mass? Well, the static frictional force would be the answer. With respect to the wheel's center of mass, there's a static frictional force acting at the point of contact between the wheel and the ramp. This results in a non-zero torque Q about the wheel's center of mass and the change in angular velocity. B. For this ramp angle, the force of friction exerted on the wheel is less than the maximum possible static friction force. Instead, the magnitude of the force of static friction exerted on the wheel is 40% of the magnitude of the force or force component directed opposite to the force of friction. Derive an expression for the linear acceleration of the wheel's center of mass in terms of m, cosine, and physical constants as appropriate. So I'm just going to show my work on the back. So there are 2 forces acting on the wheel parallel to the ramp: the static frictional force and the component of the wheel's weight in the direction parallel to the ramp. The component of the wheel's weight in the direction perpendicular to the ramp cancels with the normal force. This can be shown by mg cosine theta minus mg cosine theta, which equals to be 0. By resolving the forces parallel to the ramp, sum of forces equals mg sine theta minus the frictional force. The question states that the magnitude of the force of static friction exerted on the wheel is 40% of the magnitude of the force directed opposite to the frictional force. It means that the frictional force is 0.4 mg sine theta. So let's just replace that in. Mg sine theta minus 0.4 mg sine theta. By using Newton's second law, we can come to terms that this will come out to be 0.6 mg sine theta divided by m equals 0.6 sine theta. And there you go. Let's move on to part C. In a second experiment on the same ramp, a block of ice, also with mass m, is released from rest at the same instant the wheel is released from rest and the same height. The block slides down the ramp with negligible friction. Which object, if either, reaches the bottom of the ramp with the greatest speed? The ice block will reach the bottom of the ramp with a greater speed than the wheel. This is because there is opposing force on the wheel due to the static frictional force. The net force acting on the ice block parallel to the ramp is greater than the wheel, and thus the ice block has a greater acceleration and greater speed. Briefly explain your answer again, now reasoning in terms of energy. Well, in both cases, there are transformations of gravitational potential energy into the same amount of final kinetic energy. However, the kinetic energy of the wheel is partially rotational and partially translational, whereas the kinetic energy of the ice block is completely translational. Thus, the ice block has more translational kinetic energy and greater speed. Thank you for joining me today. I hope you learned a lot.